So last year marked the 50th anniversary of the first paper that Dennis Ritchie and Ken Thompson presented on Unix operating system. Unix, the time-sharing operating system. Hands up if you've read the paper. A few people, maybe less than about 3%, or maybe less. If you haven't, please do. What Ken Thompson and Dennis Ritchie set out to do, was change the operating model, the way people were working with computers. Instead of standing in a line to submit your badge job to a single user computer, they were changing the operating model for supporting a community of users, users be able to interactively work with a multi-user software operating system, groundbreaking, right? From the folks who raised their hands and said they had read the paper, do you remember what was the maximum number of simultaneous users that they supported at the time, 50 years ago? Roger, you're squinting? 14. We've come a long way in the 50 years. But what was really important was that they were really changing the operating model of sharing the most critical resource, time. CPU time. Fast forward 50 years. One of the most critical resources we have today is data. To power all of those fancy models that we saw on the t-shirt of data cancels, we need data. And I'm here to challenge the way the operating model for data sharing is primed to change. Data starts its life in silo applications in a variety of sources. You buy data as files. You have production systems that are generating data as byproduct of running. You have SaaS systems. But they're really not useful to find pattern matching, to do pattern matching, or use them for analytics and AI. So what happens? We push that data through a complex labyrinth and network of pipelines to get cleansed, to get aggregated, to ingest it and change it. And after that, we put it in one or multiple large-scale centralized storage or compute. I understand that the physical layer are separate, but ultimately to be computed in a large scale, warehouse, lake house, the flavor of the day. And finally, when we are about to use it, we realize we can't really understand this data because we've lost the context for it. How it was generated, who created it, what was the origin of it, and all that contextualized information was lost, so we have to just have yet another set of technologies to get the metadata from a variety of sources and get the metadata to the hands of the users. And by the time we get to use that, we realize that actually we don't really understand the data because the semantic and relationship of entities were lost, so then we have to layer a semantic layer on top of it. And maybe that helps us. And finally, well, we can't just get access to any data, so we need some sort of a catalog access management policy enforced on the data before we use it, and maybe then we can get value from it. And you know that I'm only joking because after this pipeline, there's another set of pipelines to put the data in feature stores, and you get the gist. So by the time we actually have data to use, we have created a system that has fundamentally a human and system bottleneck in the middle of it. It takes weeks to get value from the data that you generated. The business actually moved on by the time you're generating intelligence on top of it. You have built a system of brittle data pipelines that when something fails down the stream, you don't know what happened upstream. And fundamentally, trust is lost. So, I know this is comically displaying a very gloom situation, but I think the situation is going to get worse. With Gen AI, the sources of the data is going to be increased, and the variety of the data. We can't just shove every word in every meeting into a lake or lake house. So data mesh was really created as an antidote to this data pipeline-oriented operating model of data sharing, and it was created with the hope of creating this inflection point. As organizations' complexity grow, as the need for diverse data grows and the use cases grow, how can we have a system that scales with that complexity, the ratio of value to cost, the ratio of agility to growth, that remains in a healthy space? So that was kind of the purpose behind it. What it is a decentralized or socio-technical approach in sharing data the very first, when I kind of formulated the idea, I really formulated it based on its first principles. The very first principle of it is keep the data that is useful for analytic and AI in the hands of the people that are closest to it, and often in an enterprise and organization, folks in domains, like if you're a digital streaming application, if you're, I don't know, working for Spotify, for example, you have folks that are creating, building the Spotify player application, so they understand the listener behavior and providing the longitudinal view of the listener information and events. They are the best place to do it. So keep the data and in the closest to the source for direct peer-to-peer consumption. What we need to share and consume is no longer just the data, is it? It's the data, and you need to have soup to nuts, all the components that creates that data for people to be able to autonomously control and share it. So that means the pipeline, the code that's generating that data, the metadata that's being captured, the context of that data, the policy that needs to govern it. So we need to create a new thing. I call it data, the principal data as a product. Just like a product, you have control over its life cycle and you can share it like a product. And finally, for this to have any chance of being able to be materialized, you need to have a new level of infrastructure, self-serve data infrastructure to empower folks, technologists that are sitting in domains and they perhaps don't have 3 PhDs in data engineering. And finally, the model of governance needed to change to embrace automation and some sort of federated governance, because there is no centralized body to shove the data through to stamp the golden data certificates on top. So let's put it into practice. Let's imagine this fictional world, call it DAF in the book, and let's say just a company like Spotify. If data mesh was implemented, what could it look like? So in this company, we have different domains. We have folks that are building the media player applications. We have folks that are generating machine learning. They have machine learning models that classifies the user engagement, and based on that provides contextualized playlists. And folks that are working with partner platforms, Pelotons, or different perhaps places where we interact with music outside of the boundary of that company. Imagine you're a member of the team in that playlist application and you want to improve. Your goal is really increase engagement of people, listeners, with the music based on the context that they're in. You're getting data from the media player folks, the listeners, streams of events, who's listening to what and what they like. But you happen to notice that there is another corner of the organization that has access to really valuable data about the partners. What music am I liking while I'm on Peloton bike, right? So in this case, there is no centralized data team to go to. You have a way of discovering and directly going and getting access and using the data that is shared by the partner platform, partner data source. And in case you find out that you need more information that they provide, who is best incentivized and positioned to provide it is the data team within that partner domain, right? Because they are building the APIs to integrate with the partner systems and so on. Each of those teams may actually run on a different stack. The reality is that the organizations are complex. People have different choices and different, like to use different tools. So this model has to be multi-stack, has to be able to share data peer-to-peer, and the data sharing needs to be done in a way that machine learning models can be trained or analytics can be done on top. Easier said than done. If you're interested to learn more, there are a couple of books that I've contributed to, one I've written, one I've contributed to. I put 2 links underneath that gives you early free access to O'Reilly and all of their content. Unfortunately, for limited time, I can't do anything about that. So if you want to get to the books for a while for free, you can use those links. And if you read only one chapter, just read the prologue. It will give you the 2-minute short story of if data mesh was in place. So what has happened since then? Data mesh has become the next, data mesh-ish maybe, has become the next new data strategy. You can throw a rock in every direction and you probably hit a data strategy that has something to do with data mesh. I must say that the main majority adopters of this approach have been large enterprises because they have the problem of complexity, and this is a system that addresses the needs of a complex system, right? Their main motivations, having talked to 600, at least counting today, of organizations that are doing or somewhere on the journey of the data mesh, they want to have autonomy. Those domain teams want to have autonomy. They want to move fast. They want to respond with AI and data innovation at the speed of the market. They can't be really dependent on a centralized data team. The centralized data team are under a lot of pressure getting demand. So that notion of autonomy is very important. People want to use their technology of choice. There's half of the organization is using Snowflake. The other half is bringing Databricks. Everybody feels existential crisis, so they want to be able to use the technology they have and yet share data. So that's another motivation, ultimately mobilizing a larger portion of technologists that live and breathe data in domains, but they're not necessarily data engineers. Mobilizing and empowering them is another motivation for them. I must admit, this is not a technology or approach that startups will use because it just doesn't make sense. The same way that using microservices when you build a company didn't make sense. There's a level of complexity that you're introducing in your technology. Massive organizations, the biggest enterprise in the world. Does anybody know who that is? The largest enterprise in the world? Any guess? US government. US government. Department of Defense. Yes, so they are doing data mesh across the organization. We will see how that goes. It's a massive change. So what has happened? I shared this idea back in, I think the first talk I gave was at O'Reilly early 2019. There was a lot of enthusiasm in terms of, okay, how can we get one? How can we buy data mesh in a box? So the industry, the vendors had to respond fast and responded very quickly. This is the slide that I lose a lot of my friends. Hopefully you can still be friends with me after this slide. The first generation of technologies that I think responded to this for good reason were catalogs, because catalogs are a place that data producers and that data consumers meet. So they introduced the lingo of data mesh, the domains and so on, and Dataplex, Dataplex from Google, DataZone from Amazon, Atlan, Collabora, you name it. All of the data catalogs became a little bit data meshy. They introduced the language of domains. As you can see, this is again the end of the mile. Nothing has changed. Shift left at the beginning of the line. The data sharing and data production has remained the same. The second, another set of technologies that thought they can really make a change, and they have contributed to some of the data mesh implementations, are the technologies that fit in the seams of the storage, right? There are the federated query engines that can create these views on top of many different sources. And they said, well, why don't we call these views with some metadata about the domain and the people they're coming from and call that a data product and create these data product capabilities. The centralized tools also provide their version of data mesh. If you are on a centralized platform like Snowflake, I think they have embraced the language of the data mesh, the domain-oriented technology. I think it's an incremental improvement, I guess, from where we have been. And there is a category of technologies that have been used in the pipeline and ETL, whether it's low-code, no-code ETL tools or data streaming tools, that they have also tried to jump on the bandwagon. These are all amazing improvements and incremental improvements of where we're coming from. Does it materially create a transformative model, creates a new operating model? No, because we're fundamentally using the same operating model. We're just inserting some data mesh improvements, incremental changes to the system. Analysts have also their take. The Cube, actually, Dave Wanta from Cube had quite a few pieces that were really great. We had interesting chats. Gartner had their own perspective. They killed data mesh back in 2022. They thought data mesh will die before even it reaches the plateau. And if you care about this sort of, I guess, conversations, grab some popcorn and just look for data mesh and data fabric showdown, and you will get some interesting tweets and some interesting write-ups. I think that the fact of the matter is that I think that where Gartner came from was that if you follow the vendor trends and if you're looking for a vendor solution to create change, you might be disappointed, as in the organizations need to have a lot more maturity to be able to move from a centralized and decentralized approach, and that maturity might not be achieved, and the technology may be superseded by something else. From all of that, I think they've picked up the data product as something a little bit more tangible, short-term, that vendors can support, and that's what's been resurrected out of data mesh. All right, so if you allow me, I will change my hat for a minute from creator of data mesh to founder of NextData and share a little bit about what we are doing about it. Back in 2022, I was, I guess, a bit frustrated, maybe to put it nicely, about the state of technology. I thought we were at a point in time that decentralization is absolutely needed. I can't find another way. I can't really see how Gen AI with diversity of data from every corner of the planet will be fueled with some sort of a big centralized solution. So we thought about starting a company, NextData, and rethinking the system. So just like we took inspirations from operating systems. So just like Unix, I was trying to change an operating model of how people interacted with computers. We thought about, well, if you're changing the operating model of data sharing, we need to think about getting inspirations from operating systems. And with that, we thought about, okay, there is this, at the core of data mesh, there's this concept of architectural quantum, a piece of architecture, a piece of technology that can be autonomously shared and served, called a data product, with these 8 characteristics. These are the 8 characteristics I put in the book when I describe what this concept needs to be. A data product as an architectural quantum needs to be discoverable, needs to be addressed independently, needs to be natively accessed, right? So if a data scientist wants to access that data as a bunch of embeddings versus a data analyst wants to run it as SQL on a relational data, it's fundamentally the same semantic of the data. This unit should be able to serve that. It needs to be understandable. Like, we can't just get to the data and say, oh, I don't really understand this. Give me the metadata or the lineage or the graph on top so I can understand it. So understandability needs to be baked in. Interoperability, again, access across different platforms is a must. If you're thinking about a planet scale kind of exchange of data across the boundary of organizations, we must think about exchange of data across the boundary of technologies. Trustworthiness needs to be baked in, bridging the gap between what people know and what people don't know with the documentation, computational documentation that you can run against the data, with the metadata, with the SLOs. All that gap needs to be filled, and all that gap needs to be filled by this unit, which we call data products. And of course, it has to be secured. So this is a lot to build, and again, we're not very creative, so we're just getting inspirations from what exists out there. So we thought about this as really as a concept of a container that orchestrates all of the bits and pieces that need to come together to provide those 8 characteristics. And what I'm sharing with you is not even on our website yet, so it's a little bit early days in terms of product launch. So this container, again, just like a Unix process that needed to have streaming and pipes in and pipes out. So it has events in and access the data with computational APIs on top of the data. It has policy, it has data metadata, it manages code and compute for generating and also access the data, and also a set of APIs for its discoverability and control. And again, just like an operating system, it has to have a system of drivers that extends storage and compute on a substrate that supports a variety. The icons that I put here are just nominal. They're not the actual real, all of the technology we support. It's a little bit of a selection of just giving you a hint of what substrate exists out there. We're not reinventing storage, or we're not reinventing compute. We're just pushing down both compute and storage to the underlying substrate. So that's kind of where we're at in the beginning. And of course, again, just like an operating system, you don't get just Unix processes with a bunch of pipes and drivers. You need a set of tools to be able to build these products, and you need a set of tools to be able to discover them. We take an API-first approach, so every piece of technology that we build, whether the container operating system is accessible through APIs for you or the users to connect, but we provide a few build tools to run and manage containers, and a few tools to kind of discover and trust. So some of the principles that we applied in building this container is semantic first. Semantic is not something that we build derived. Semantic is what is described first. The syntax and serialization might vary between that kind of algebraic model that describes the semantic and what actually gets stored. It is programmable, as in we think that we should meet the programmers where they are. If somebody's using, R to generate data and somebody else is using pandas to generate data, we should meet them. So we don't actually change that. We encapsulate that. Multi-stack, multimodal. The beauty of, I think, a system that is designed bottom-up as opposed to layer down is that a lot of those phenomena, such as semantic layer, such as lineage layer, becomes an emergent phenomena. As in, once you have a few of these independently defined and connected, semantic layer emerges, the knowledge graph emerges, the lineage graph emerges from that. And I think that's super cool. What does Gen AI? I couldn't have this talk without Gen AI, of course, in this slide. So for many of you who are building technology, I think it's just given, right? We cannot fundamentally have a technology that doesn't have this capability built in. And I think that's the obvious ones. I mean, we can all think of obvious places where Gen AI can be used, or LLMs can be used. We've seen a lot of movement in natural language, yet another movement around natural language interactions with any body of knowledge or any system. So for us, it's the same. We have seen, we have to support native connection of data, whether it's for RAG or training using embeddings, that has to be baked in any system. Those are given, those are the obvious use cases of Gen AI. I think the place that Gen AI can be really impactful is where an organization is going through a transformation. There is this hostile relationship between creating change and changing behavior and moving fast. You see technologies or transformations that take off really fast but crash land. And you see some that take off slowly but run out of fuel, never make it to destination. The ones that when we talk to a lot of enterprises or folks that are adopting some form of a data mesh, they really want to move fast. They want to, in a blink of an eye, have a mesh, created, and of course, buying technology is something like a catalog that can pull out tables and label them with some metadata, call it data mesh. Yes, that can make you move fast, but that fundamentally doesn't create trust. That fundamentally doesn't bake in quality. So if we tell them, no, you've got to change that. Hold on a minute. We've got to get every developer and data product developer now build data products, that's going to take months before you can get value, and you run out of money or attention or interest before any change happens. So I think really where Gen AI can help is being a transformation co-pilot for the organization. And in this case for us, it's really cold bootstrap of the mesh from the existing, a spread of Python scripts that live in different places or a spread of data that lives in places, and bootstrap that initial set of data products, and that then augments the human workflow. And I think that's where really Gen AI can make an impact, and I would encourage for any organization who's on a transformation journey or any product that is a transformational product to think about that bootstrapping scenario. Whether you use something like our system or build your own, integrate your own, there are 4 hard problems to solve. The first hard problem is to codify a developer experience that creates data as a product, whatever your definition might be. A discoverability across systems, across teams, across platforms that is dynamic and it doesn't require human curation. Data exchange through heterogeneous APIs designed for ML and AI, which is a very different set of APIs. If you think about it, the APIs are not necessarily get the data and then put it in a feature store. Actually, the APIs need to move the compute to the data, which is a topic of probably another talk. And finally, data governance, right? We have to rethink policy as code and really rely on automation the same way that zero trust architectures back in the day when we moved to cloud enforced that and brought that to the foreground. So that's governance must change. Whatever you do, whichever technology you build, however you do it, I'll just have one ask to leave you with. For decades, we've been told that mechanical sympathy is what we need to build systems. Who knows what mechanical sympathy means? All right, so you should read Martin Thompson on it. The mechanical sympathy actually came from I think Formula One or car race drivers. We were told that you need to understand the mechanics of the system you're using before you can use it or change it. the same way that the drivers need to know how the car works, the same way programmers need to know how the system works. And I think we have over-indexed too much for the last decade or so for our data infrastructure. And the next generation data infrastructure needs to have a little bit more human sympathy, as in not requiring humans to know exactly how to index the database before they can write a pipeline or a data product on top of it. And human sympathy, systems built with understanding what motivates humans. And what motivates humans is ultimately autonomy, mastery, and feedback, getting feedback from the users. So I just leave you with that. Hopefully this was helpful to you. If you are a Rust engineer working on distributed systems and data, we are hiring. If you want to see the system in action, click early access on our website, and we're happy to give you a demo. Thank you.